Well, yesterday we looked at angles and standard position, and we looked at and we said the initial ray is always on the positive x-axis, and the terminal ray um, is the other end of the angle, is the other ray of the angle, um, and depending on the size of the angle, that decides where the terminal ray exists in our four quadrants here. And we also counted off different. I guess on this one we did multiples of 30, so 30, 60, 90, etc. And we did a full rotation. 0 degrees is where our initial ray is. But if we go all the way around, a full rotation, 360 degrees is also where that terminal ray of a 360 degree angle ends. So today we're going to do something similar. But first we need to look at what a radian is. Radian is actually an angle measurement, and once you get out of geometry and early physics, whenever you're talking about a angle measurement, most of the time you'll hear it in radians. So just to talk about what a radian is here real fast. So here's a radius length. The radius is the distance from the center of a circle to any point on the circle. I drew it here, I could have drawn it anywhere. But imagine taking this radius, which is straight, and taking that and bending it so it matches the curvature of this circle here. So let's just see how many of these radius lengths that are curved, let's see how many of those radius lengths fit around here. And I'm going to just do my best to approximate just to make a point here. So here's our first one. So 1, 2, 3, 4, 5, 6, and then there's a little bit of space here. So a little more than 6 of those radius lengths go around the circle. So what is a radian? A radian is the angle formed by one radius length curved around the circle. So this right here is 1 radian. And there's a little more than 6 that go around that circle. In fact, 2 pi being 3.14-ish, 2 times 3.14 is 6.28-ish again. So that's that 6.28 is a little more than 6. So there's actually 2 pi radians in 1 revolution. Another way to say that is there's 2 pi radians. What's a revolution in degrees? 360 degrees. In fact, you can see it here. In 1 circumference, that's a revolution of the circle. What's the formula for the circumference of a circle? 2 pi radius lengths. 2 pi radius lengths are in the circumference of a circle. So 2 pi radians for 360 degrees. Let's break that down here a little bit. So if 2 pi radians is 360 degrees, let's take half of that. Half of 2 pi's is 1 pi. So half of 360 degrees is 180 degrees. So 2 pi radians is all the way around the circle, 360 degrees. Pi radians, half of that, is half of 360 degrees. So halfway around the circle is pi radians. And we can continue to break that up. Let's break pi radians up. Let's take half of that. Let's take a fourth of that. Let's take a third of that. And let's take a sixth of that. So we're going to take half of both of these. So half of pi, I'm dividing it by 2. Half of pi radians, what's half of 180 degrees? Well, that's 90 degrees. So half of pi over 2 or I'm sorry, pi over 2 is the same thing as 90 degrees. Let's take a quarter of these values. So a quarter of pi and a quarter of 180. Let's take a third of these values, a third of pi, pi over 3 radians, and a third of 180. That's 60 degrees. And then let's take a sixth of both of these. So a sixth of pi and a sixth of 180. So notice these values here, and even compare them to what we were talking about yesterday. So notice all of these were multiples of 45 degrees. All of these are multiples of 30. And the other angle we just mentioned was at a 60 degrees. So hopefully you're thinking, all right, 90, 45, 60, 30. Hopefully at this point your memory is being jogged about special right triangles. We have a 45, 45, 90 right triangle. We have a 30, 60, 90 right triangle. And that's the reason we broke these up the way we did. So for your practice today, you're going to be in radians now, showing one full rotation. I'll do this one with you. Okay, pi over 3 radians. You're going to do one full rotation of pi over 4 radians, pi over 2 radians, and pi over 6 radians. So I just want to show you how to do that. I'll work through the first one with you, and I want to give you guys some time to work through the other three. All right, so let's see. First of all, pi over 3 radians. I know it's going to still sound confusing to you. So if it does, come back over here and say, what is pi over 3 radians? Oh, that's a 60-degree angle. So I need to draw a 60-degree angle. And if you need to, go back to yesterday's assignment. And right here is that 60-degree angle. So I'm going to draw that. Here's our initial ray, always on the positive x-axis. And I'm going to do my best to draw a 60-degree angle here, terminal ray. So this angle right in here is 60 degrees. I'm going to write 60 degrees. I'm also going to write pi over 3. Let's go another 60 degrees. Let's go two 60-degree angles. And for right now, it's probably going to be easier for you guys to continue to think in degrees and then move it back into radians. So two 60-degree angles is two of these. So 60 and another 60 gets us up to 120. So how are we going to draw 120? Well, 120 is 90. Here's our 90-degree angle, our right angle, and another 30. So right here, I'm going to say that that's 120 degrees, which is two 60-degree angles. Two 60-degree angles is 120. I'm also going to write it in radians. I'm going to write 2 pi over 3s. Pi over 3 is 60 degrees. Two of those is 2 pi over 3 radian angles. All right, let's do that again. Three 60-degree angles. 60, 60, 60 gets us up to 180, and there's our straight angle there. 180 degrees right here. So that's 180 degrees. Well, what is that in radians? That's 3 of these. So here's 1 pi over 3. Here's 2 pi over 3. And over here is 3 pi over 3s. And you might be saying, well, why did you say it that way? I wanted you to see that you could count through the radians. 1 pi over 3, 2 pi over 3, 3 pi over 3s. And you might have said, well, we can just reduce that and call that pi radians. And isn't that true? Isn't 180 degrees pi radians right here? Okay, let's keep counting. Another 60-degree angle is going to be about right here. So if we have 1, 2, 3, 4 60-degree angles, we're up to 240 degrees. Well, what is that in radians? It's 1 pi over 3, 1 60-degree angle, 2 pi over 3, 3 pi over 3. What's next? Yep, 4 pi over 3. All right, another 60-degree angle. We're over here now. Another 60-degree angle is 300 degrees. And where are we in our pi over 3's? 1, 2, 3, 4, 5 pi over 3's. And then the last one, another 60-degree angle. Look at that. What's 60 more than 300? 360 degrees. That's a full rotation. And what's another pi over 3? Here's our fifth pi over 3. What do we get when we get back over here? It's our sixth pi over 3. 360 degrees. What is 6 pi over 3 reduced to? And see if you can make that connection that we were talking about earlier. Doesn't this reduce to 2 pi? And what is 2 pi in radians? It's a full rotation. So what you're going to be working on are the next three here. You're going to count by pi over 4s if you need to. Look here, you're going to be counting by 45s. Over here, pi over 2s. Again, just use the reference. And then over here, you're going to be counting by pi over 6s. You're actually going to have a lot of little terminal rays in here. Okay? Try it out. Stop by my office hours if you have questions. Good luck.